Catastrophic events have become one of the most popular topics in cinema and literature. Yet it's strange that out of hundreds of apocalyptic scenarios, the most realistic and dangerous one, something that's not a question of if, but when, gets the least attention. And even when it does, it usually sneaks into modern media through metaphorical references, often in the works of fantasy writers. Life on Earth has existed for roughly 4 billion years. About 2.5 billion years ago, during the Proterozoic era, complex life forms like plants, fungi, and animals began to emerge. That's also when the first major catastrophe occurred. There are many theories about what caused it, but one of the most likely explanations is the rise of photosynthesizing organisms. These life forms consumed carbon dioxide and released oxygen. At the same time, volcanic activity decreased, which made the atmosphere clearer and reduced the greenhouse effect. As a result, Earth entered its first ice age. The planet's average temperature dropped from around 35 degrees Celsius to below 10. Some theories even suggest that the planet froze completely, with ice covering everything, including the equator. Unfortunately, geology and paleontology offer little information about this ancient time. Over several hundred million years of this ice age, primitive life likely survived only in a few isolated spots. Fossils of multicellular organisms from this frigid period are extremely rare. Afterward, for over 1.5 billion years, the climate was warm. The planet's average temperature was about twice as high as today, and there were no polar ice caps. But around 720 million years ago, a new period began with a name that says it all: the Cryogenian, from the Greek word for cold. At the time, all land masses had merged into a single supercontinent, blocking much of the equatorial zone. Due to complex chemical reactions, some of the carbon dioxide became trapped in rocks, and the planet essentially froze. Literally. This theory is called the Snowball Earth hypothesis. The climate resembled modern Antarctica, with temperatures of -40 degrees Celsius even at the equator. Since carbon dioxide was locked in rocks and the ice reflected sunlight, the only thing that could warm the planet back up was volcanic activity. But it took nearly 100 million years for enough greenhouse gases to accumulate. About 500 million years ago, a new eon began, the Phanerozoic. During this time, life forms became incredibly complex and diverse. Around 540 million years ago, the Cambrian explosion occurred, bringing an astonishing variety of new species. The climate was so warm that oxygen isotope analyses suggest polar sea surface temperatures were around 20 degrees Celsius. Temperature differences between latitudes were smaller than they are today. Then, roughly 310 million years ago, another ice age began. Its coldest phase lasted about 40 million years, covering much of the planet in ice. The ice sheets were likely larger than they are now. One probable cause was the Carboniferous period that preceded it, during which trees, due to high oxygen levels, didn't fully decompose but turned into coal. This process trapped carbon dioxide in rocks, reducing the greenhouse effect. After the Paleozoic Ice Age ended, the climate became warm again. For more than 200 million years, the planet's average temperature remained above 20 degrees Celsius, with occasional fluctuations. Polar ice caps and winters as we know them didn't exist, but everything changed, not during the extinction of the dinosaurs but much later. 66 million years ago, Earth entered the Cenozoic era. In northern latitudes, average temperatures were above 20 degrees Celsius, and even Antarctica had subtropical climates. For the most part, a tropical climate dominated Earth for nearly 2 billion years. But 34 million years ago, the planet cooled again, causing another extinction event and the reappearance of polar ice caps. The climate became colder, drier, and more seasonal, with distinct climate zones. In geological terms, Earth only recently entered a true ice age, about 2.5 million years ago. Since then, the planet has alternated between cold glacial periods, when ice sheets grow, and warmer interglacial periods when they shrink. Technically, the presence of polar ice, permafrost, and winters with sub-zero temperatures means we're still living in an ice age. More precisely, we're in an interglacial period called the Holocene, which began 12,000 years ago. The last major interglacial, the Mikulino, started 130,000 years ago and lasted about 15,000 years. During that time, the climate was warmer than it is today, and climate zones were shifted several hundred kilometers farther north. A shorter and less warm interglacial period began roughly 45,000 years ago, when modern humans were spreading across Europe. In fact, over the last 2 million years, there have been about 10 warm interglacial periods, which together account for only 20% of the time. The remaining 80% saw ice sheets grow, and the climate was colder than it is today. In academic literature, the current Holocene epoch is considered an interglacial period, meaning there's absolutely no basis to say the Ice Age has ended, especially since the warmest phase of the Holocene, known as the Atlantic Optimum, is already behind us. If predictions about rising global temperatures in the 21st century hold true, we might reach similar levels. Some might argue that humanity has pumped so many greenhouse gases into the atmosphere that another glaciation is unlikely. However, if we look at carbon dioxide levels over the past 600 million years, they've ranged from 200 to 5,000 parts per million. For reference, the current level is about 400. Even within the last million years, there were periods with higher levels. And while greenhouse gases are often discussed in studies about paleoclimate, and they certainly affect the climate, they're just one of many factors. In 1999, Professor Weiser demonstrated that there's no strict correlation between the amount of greenhouse gases and climate change. The climate is influenced by a ton of factors. One of them is the Milankovitch cycles. To put it simply, the Earth orbits the Sun on an elliptical path and from time to time changes its tilt angles. At certain points in history, like around 12,000 years ago, the Earth and the North Pole start receiving more solar radiation at a particular angle. When this aligns with other factors, it triggers a warming phase. The Northern Pole plays a key role because its ice sheets spread out over the continents. On the Southern Pole, the surrounding ocean prevents glaciers from expanding as rapidly. And here's the thing. What makes a glacial period truly terrifying isn't just the freezing temperatures. Even during ice ages, seasonality can still be traced. And even in central Eurasia, there is summer with positive temperatures. The real issue is that overall cooling prevents snow in the north from melting. Over time, the snow compacts into ice, lowering sea levels and creating massive ice walls, typically over a kilometer high. These enormous glaciers slowly advance southward, reshaping landscapes and obliterating everything in their path. In past glaciations, the ice sheet rarely extended further south than Kyiv. However, during the Dnieper glaciation, which began around 3,000 years ago, it reached as far as Dnipro, formerly Dnipropetrovsk. Cities like Warsaw, Minsk, Moscow, Voronezh, and Tambov were buried under more than a kilometer of ice. This is one of the reasons why our Homo genus and the Homo sapiens species evolved in Africa. Attempts to settle Eurasia mainly occurred during warm interglacial periods. But what are the odds of another ice age starting soon? Between the 14th and 19th centuries, humanity experienced a temporary cooling period known as the Little Ice Age. Since the 20th century, we've been in another warm optimum, which typically lasts only a few centuries. By the way, while ice growth or melting does impact sea levels, one puzzling fact remains. You'll find plenty of sources claiming that if all glaciers melted, sea levels would rise by 60 to 80 meters. There's also data suggesting that the Arctic ice cover has shrunk by about half since the mid-1970s. Yet, during the entire 20th century, sea levels only rose by 17 centimeters, and the current rate of increase is around 3 millimeters per year. Right now, global temperatures are rising and approaching levels seen during the last Atlantic optimum, and they might even surpass them. It seems like there's no chance of another ice age anytime soon. But there are a few inconvenient details. First, according to the Milankovitch cycles, we're already in a less favorable position to receive high levels of solar radiation, which means less heat. Second, as far back as the mid-20th century, American geophysicists Maurice Ewing and William Don suggested that glacier growth accelerates when the Arctic Ocean is at its warmest. Warmer waters lead to greater evaporation, fueling heavy snowfalls. The snow, in turn, reflects sunlight, encouraging ice growth. This hypothesis is also supported by Vladimir Kotlyakov, a Russian academic and renowned geographer. According to Kotlyakov, the planet is already in a cooling phase. Who knows, recent extreme cold spells in Siberia or events like the Texas winter storm might be the first signs of a new ice age. The ice age isn't over, it's just taking a coffee break. Whether it's back in a few years, centuries, or millennia, nobody knows. But research shows that even today's mild interglacial climate, with its cozy 15 degrees Celsius average, is colder than much of Earth's history. And as for that ice monster creeping toward our cities, get ready for full winter gear. It's just a matter of time.